Hello guys, how are you all doing? So I see that a few people haven't submitted our assignment. Please don't be late. You should submit it as soon as possible. I noticed this none of the group have uploaded them in the designated folder. So there is an assignment folder in the resource section. Each group must create a CSV file with all the test cases. Once all the test cases are combined into an Excel sheet, import the CSV file into the Zephyr squad. Okay. A quick reminder about your Jira Confluence subscription is they are valid only for a month. If you don't complete your work before the subscription ends, you'll need to create a new account, which is time consuming. So you should do it as soon as possible. Okay. Now let's begin our session. First, let's see if you can remember what are aggregate functions. Can anyone tell me what aggregate functions are? So, aggregate functions are used to calculate an overall outcome or score for a column. These functions help us analyze data collectively instead of row by row. So, aggregated function is overall outcome of a column. So, aggregate functions are used to calculate an overall outcome or a score for a column. These functions help us analyze data collectively instead of row by row. So, what are the examples of aggregate functions? They are minimum, maximum, and count. The minimum function returns the smallest value in a column. The maximum function returns the largest value. And the count function helps us to find the total number of rows. For instance, if we execute and execute a query to find the maximum value in a column, it will return a single value because it represents the overall outcome of the column. So it represents the overall outcome of that column. The same goes for minimum or count. These functions summarize data into a single and concise result. Now, why do we use limit clause? We use limit clause to restrict the number of rows returned by a query. For example, if you want to fetch only the first 3 rows or the last 10 rows, you use the limit clause. So let's see an example here. Here we can see wrote select from a student limit 3. This will return the first 3 rows from the table. So does the limit clause delete duplicate rows? No, it doesn't. That's a misunderstanding. The limit clause is only for restricting rows, not for deleting duplicates. For removing duplicate rows, we must use other commands, not limit. Clear? So limit clause is for restricting rows. And then next, why do we use distinct clause? We use a distinct clause to retrieve unique values from a column. So it brings out the unique values. For example, if you have a table with repetitive age like 18, 18, 19, and 20, you use distinct on the age column. It will return only 18, 19, and 20. Okay. For example, if you write select distinct age from students, this query fetches unique age values ignoring the duplicates. Now, can anyone tell me what an alias is? An alias is used to rename a column or table temporarily in a query. So it is a temporary column. It is often used to make it more readable. For instance, if you write select customer ID as ID from customers, the customer's ID will be renamed into ID for the output. Now, what are nested queries? A nested query is also called subquery. A query is a query embedded inside another query. This inner query runs first and its result is used by the outer query. Okay, so it is a query inside a query. For example, if you write select from students where age is greater than average from students, this inner query calculates the average age and the outer query fetches all students older than that average. Now let's dive into table relationship. Imagine you own a store. You have two tables. Okay. So you have two tables. One is customer and the another one is orders. So the customer tables stores information about your customers, such as their ID, names, contact details, etc. And the order tables tracks orders including items purchased, quantities, and orders ID. So here you can see customer ID and order ID are unique identifier. A unique identifier for each customer and a unique identifier for each order. If a customer, say here Rafi, places an order for a pen, the system generates a unique order ID. If he orders again another day, the system assigns a new order ID, but his customer ID remains the same. So why is this important? It is important because it ensures that each transaction is traceable and no two customers or orders are confused. Now, what happens if two customers have the same ID? It would cause confusion, making it impossible to differentiate between them. Now, imagine you have a stationery shop, you have 10 pens in your inventory. So you have 10. A customer named Rafi walks in and buys a pen, leaving you with 9 pens. Now let's add a twist. Rafi breaks a pen and decides to return it not once but repeatedly. As a business owner, you are now in a dilemma. Should you keep Rafi's data in your system for future transaction? Would you still sell to him after all these incidents? The likely answer is no. Why? Because such a customer brings complexity and risk. To ensure such cases don't slip through the cracks, we need a way to track customers effectively. Let's use our database example to illustrate this. Now, this table I am showing you contains details of all customers. Each customer is assigned to a unique ID, customer ID. For example, there are two customer named Rafi, and but they have two customer IDs. This table tracks the transactions or orders. It records the what items were brought but doesn't initially have the customer ID column. Now here's the problem. If a customer like Rafi repeatedly returns or breaks items, how do we identify the specific Rafi causing trouble? Without a clear connection between the customer tables and order table, it becomes confusing to track behavior. To solve this, we add a customer ID column into the order table. This creates a direct link between two tables. So customer ID in the customer table is a primary key. Okay. So customer ID is the primary key. It uniquely identifies each customer. For example, if a new customer registers, they are assigned a new unique customer ID. When the customer ID is added to the order table, it becomes a foreign key. A foreign key connects the order table to the customer table. So it connects order table to the customer table, foreign key. It enables us to track transaction back to the specific customers. With customers ID in both tables, identify problematic customers becomes straightforward. For example, if Rafi, which is customer ID 101, repeatedly breaks items, we can see all his orders in the order tables using the customer ID. So, what are the difference between primary keys and foreign keys? The primary keys are unique identifier within a table. For example, customer ID in the customer table. They are always unique and can be duplicated. The foreign key is as it establishes connection relationship between tables. For example, customer ID in the order table. It can be duplicated and it connects to a primary key to another table. Okay. When two or more tables are connected using keys, primary and foreign key, the system becomes a relational database management system. Previously, database operated as database management system without any relational capabilities, leading to challenges. The relational database management system solved the issues by allowing relationship between tables. So suppose there is a customer table, then there is order table. So here is customer ID, here is order ID. The customer ID is assigned to customer table and order ID is assigned to order table. Now it is connected to customer ID. It is a primary key which is unique. and it is foreign key, which establish relationship. And the connection here is relationship database management system. So by adding customer ID to the order table, we can now track Rafi, which Rafi, like Rafi 101 or Rafi 102 is associated with which order. Now, in order to view information from two tables, you can select from a student, then retrieve all data from to retrieve all data from student details. You can write select from student details. Okay, this will show all the tables data. Now, if you need columns like name, grade for the same table, then you can write select name, grade from student details. Since grade isn't in the student table, running this on a student will produce an error. Now retrieving columns from different tables. Now you can write select student.name, then student details.grade from student details. This query lists all combination of names and grades leading to inaccurate results. For example, Ram appears to have multiple grades. The system doesn't inherently know how to relate rows from one table rows to another. Now, why do we use aliases? We use it to simplify long and repetitive table names. It's easier to read and write queries. Now, to assign alias, you can write select as.name, then d.grade from student as, then student details as d. It also results the same product since no relationship has been defined yet. To add relationship, you can use a common column, like for example, role, to establish this link. So you can write select as.name, then d.grade from a student as and student details d. Then where roll num as dot roll num equals d dot roll num. Okay, it will create a relationship between the two tables. Then you can see the results. So you can see here is it combines rows from both tables based on the matching roll number. Then only relevant rows are retrieved here. So you can see only the Suji's grades are showing here. Now, for example of a lengthy table name, you can write number of row. Then you can use meaningful aliases like select e.name.e.salary from number of rows, employee updated data as e. It ensures you are working within the correct database. You can use database name. Without this, the system cannot identify the tables or their columns. So without specifying a relationship, results will be a Cartesian product, leading to an incorrect data. Aliases are temporary and only valid within the query they are used in. For example, select star from S. This will result in an error unless S is redefined. So always define relationship between tables when retrieving data across them. Use aliases to simplify your queries, especially when dealing with long table names. Now, suppose you can write a query, select c dot name o dot item from customer c orders o, where c dot customer id equals o dot customer id and c dot phone equals 1 2 3 4 5 6. This query aims to retrieve the name of the customer and the item they purchased from two different tables, which is customer and orders. The connection between two tables is established using their common column, customer ID, which acts as a primary key in the customer table and a foreign key in the orders table. Now, C is used as a shortcut name or alias for the customer table, making it easier to reference columns from the table. O is the alias for the orders table. This simplifies the query when dealing with multiple tables. Now C.name fetches the name column from the customer table and O.item fetches the item column from the orders table. The where clause specifies C.customer ID equals to O.customer ID. This condition connects the rows in the customer and orders table, ensuring that the data retrieved corresponds to the same customer. And C.phone adds a filter to include only the rows where the customer's phone number is 1 2 3 4 5 6. So the query will return a list showing the names of the customers and the items they purchased, but only for those customers whose phone number matches the given value, which is 1 2 3 4 5 6. Okay? Now let's see here. So you should ensure that you are working on the correct database, which is practice for TB. Then verify the structure and data in both tables using select from employees to and then select from department. So here you can see that from employees to there are columns called first name, last name, salary, department ID. And from department, there is department ID and department name. The department ID column serves as a primary key in the department table. It acts as a foreign key in the employees to table, linking the two tables. The goal is to retrieve the following first name, last name, salary of employees two. So you can use aliases for table names. To do this, you can write select employees to name as alias A and department is alias B. Okay. So after running the program, it will show the department name, salary, first name, and last name. So you can write select A dot first name, A dot last name, A dot salary, B dot department name. From the employee to as A and department as B. Where the department ID, A dot department ID equals to B dot department ID. The column retrieves the employees to table and B dot department name column retrieved from the department table. Then specifies the from clause specifies the two tables involved in the query. The where clause links the two tables using the primary and the foreign key relationship. Here you can also find the employees aged at 18, suppose, by writing the where clause. Where the age is equals 20, 18, it will show the results of all the students. And if you want to rename the tables, you can use alter table function and use the rename clause to rename the table. Okay, now in order to calculate the total salary of the employees, you can write select sum clause and bracket. Use bracket and put salary inside from employees to. It will show the sum of all the employees to table. This query gives you the total salary of all employees. Now let's say we want to sort the data in a particular order. To do that, we use the order by clause. So can you anyone recall how we do it? So you can use order by first name. It will show the order and the name of the employees into the ascending order. The order by allows us to arrange the data. For example, if you want to order by first name, you can use this. It will default to set into ascending order. So let's try it. I will order the names into ascending order. So here you can see that the result is shown. Johnny, Ronnie, and Steve. It's ordered alphabetically by the first name. If you want to use descending order, just use DESC. Okay. Now, let me show you another thing. You can also use aliases in SQL. For example, if you want to display the sum of the salary with the custom column name, you can write select sum salary as total salary from employees. It will rename the table in temporarily total salary. Now, if you run the query, you will see that the column name is changed to total salary instead of the result sum salary. This is useful for better readability. Now let me demonstrate the count function. If you want to use the number of rows in the table, you can use the count function. So you can write select count as total rows from employees to. So this will give you the number of total rows in the table. It's different from the other aggregate functions because it works with all columns, not just the numeric ones. You can also change the color of database tables and columns to make things easier to identify. For example, to color the database blue, select World Database and choose the color from the drop-down. You can use the same for the column like city. It's just for better readability and doesn't affect the SQL execution. So in SQL is just for the visual purpose. For in documents, you can use also apply text colors for clarity. Just follow the same steps as I showed you. Now, before we finish today, Remember to complete all tasks, including practicing the queries from class 19, 20, and 21 and 22. I will upload the slides for you to refer to. Also remember that for the interview they will give you scenarios and you will need to create queries based on them. You won't be coding live, but you will need to demonstrate your understanding. Now, any questions before we wrap up? Uh, if not, then you should focus on practicing and being well prepared. Now, all right, take care and have good night. See you in the next class.